Hello, welcome in my next row hacking video, and today I will implement slices. Slices are something that is known from Rust or Zig or I think many programming languages have slices now, and slice is basically a view into some memory. So let's say you have an array 1, 2, 3, 4, 5, and you want to pass a unknown some part of that array, but there is not known how big that part is. You want to pass to some function and let's say print it. And in C++, in older versions of C++, you would need to do. You would need to do, like, if you have an array, which is something, and like, for example, you have this function memcopy, and it will take a pointer and a size, like 2 arguments, and obviously a destination. I'm not sure if I remember correctly the order, but like, the point is that you need to have 2 arguments to pass a single thing, and slices are something that are meant to solve this, because then you need to pass like only r, the function that takes a slice. So you can take a slice of destination or a pointer of destination and a slice of like source. So that would be like, there's no good equivalent C for that, but like, this is just like, I hope you get the point. So here, I think that's a good syntax. I think Zig uses that syntax. At least I don't remember Rust, but like, this syntax says that it's a slice of U32. So you are passing a unknown number of U32 to the print function, which you then print in a iteration loop, like range 4, basically. So let's start hacking on that. So I think we could start from syntax. So parser cpp, but that would be, I think, I think we have all required tokens for that. We just need a brace close, brace open. So I think we can use code for parsing array types, which apparently takes the size and the type, and we could even make a optional or no. Oh, okay, let's keep it simple. So on the parser side, we don't even distinguish between arrays and slices, because here array is just like, slice is just array without known size from the point of syntax. But okay, so if this is optional, we can also, I need to make a fixed formatting. So if there is a size, we would print with the size, and otherwise we would print just the empty array. Okay, and then where we are parsing that array type. Okay, so there's a size token which we expect, but then if we need to add a special case, so if there is no other So if next token is not number, we'll just expect a closing and return a pass array type with without a size, so empty size. Okay, so this won't compile because it will fail in type check, I think. Yeah, so no, I think in type checker we need to distinguish these two because they will be code gunned entirely separately and they have completely different semantics. Like array, if you do a array, like it's a value, so it's stored where you declare it. They like these 10 U32s are stored in the same place this variable is declared. So for example on this stack or directly in this tract. So I think yeah. But slices are just views into memory that is owned by someone else. So you can do slice to the array, and this will point to the slice is just a pointer. Like, it doesn't own its memory, so you need to be very careful when passing slices around, and that's I think why I will prevent some operations on slices. So like you will be able to assign slice only to I think local variables and like variables that are in the same scope basically. So that's kind of a simple borrow checker, like in Rust, but not that complicated. So okay. I think we have a single place where it fails currently. Well, it fails to compile, which is here because we are just copying this. So let's have an array type and a slice type, which is inner, which has a name obviously, which can be compared, and which is iterable with the inner, so we'll just return that. What is wrong with that? Found array, yeah, okay. So let's go to so first let's make the name, which is slice type. It's very similar to the array, but doesn't have a size here. Okay, and then the iterable type would be also inner. And we have now we need to do a if here. So if type size, if there is a size, we do an array part, and otherwise we return a slice. So the type would be slice type with inner, which is the inner type. Something like that. think what's wrong. Oh, I haven't added to the variant. Okay, so slice. I think I'm sorting this alphabetically. Let's do it in the same way here. So we have, well, primitive type is in under order, but that's not important. No. Okay, so we have this simple code, and also I think it breaks again somewhere because I don't know. It will fail in the code again because we need to code again a std span. No. So now primitive array function slice, which we code in as a std span. So copy this thing, but no size here. We can try it because we use a write directly, which handles errors. Drop this thing and span. What do we add const here? I think that this is a very important question because we can have mutable. We can have mutable slices or mutable, or the thing which slices points to can be mutable. That are two separate things. And now I think this will. The language doesn't know anything about references, so it will just treat the non-mutable, the const slice will treat as a you wouldn't be able to either change it, like this slice itself, but you won't be able to change the elements the slice points to. So, like, you either have slice, const slice pointing to const array, const element, or mutable slice pointing to mutable elements, which is not ideal, but okay for the first iteration, I think. So let's build that and see if it works. Okay, so I forgot a return. Okay, so now we can run a test. So bootstrap ASL tests arrays slice. So yeah, array index must be an integer array, and that's okay. Yeah, I haven't even implemented that operator. That's I think because we could introduce many ways to get a slice from the array, from the owned array, and that's the obvious one. Like, you just take a just hard-coded array size here and pass the slice of the entire array into a function, but here I hard-coded is like this, that span. I hard-coded the range, which is not ideal. I would want to do like array size or even something like that, which would signify like there is no start, there is no end, so just take a entire array. That would be nice syntax. You could do something like in Rust, so just take a reference, and then it's obvious that you are taking a reference. Or you could do also it You could also do it implicit, but then if you pass a mutable array, you wouldn't know that you're passing a mutable array unless we would do something also taken from Rust. So you need to, if you're passing somewhere a mutable reference, you need to precede that, like that binding with mute. That's also a nice option. I think what would be the easiest one to do? That option would require to overload the operator, a like random access indexing operator. That would require a new syntax. But then I think it's sake of implementing a new operator, and that also would require a new syntax because we don't have the reference syntax. So I think let's do the first option for now. So currently we have array index must be a unsigned integer. Let's search for that. Okay. Now we have that error, but we also want to take a range. I think we can even or a range. But it would like then we'll have as this returns, okay, this just switches over types, and that's I think okay until we have overloading. So let's do, if index is u32, we'll do that. Otherwise, we'll return an error, but there is that another case when the index, like the array type is, no, the index type is a range. So range type ID we have here. Also, let's copy that error, not found operator for range. Array type. And then we need, I think we could even use visit here. So, actually we could even port the old thing to visit too, but let's write the slice part. So visit overloaded a array type, and then we have array type. We could we could have also primitive type, but let's focus on arrays for now. So all another options will just error out. So not found operator for the type, yeah, and better range. So that type would be, then we'll return a invalid expression, I think. So here we'll return a invalid expression. And here we'll return a expression of array index, yeah, which we could even make here at the start thing, make just here, so expression. We can even switch it types here, okay, and something like that. Then we won't need to duplicate that logic. But we override something, so what? X. Oh, I think I shadowed the argument, yeah. Okay, so maybe that, and then that would use expression. Array type. Then here we also pass a array expression, and as a type we pass a slice, I think, which will need to construct here somewhere here. So auto slice, we'll get slice of inner, so get type thing, no, get or add. Or get module. Get or add type, which is slice type. And that will have a array inner as its type. So type ID would be slice and the expression would be but yeah, there's that mutability question which we'll answer with, I think we'll just do mutability of that would be mutability of a array. So I guess we just copy the mutability from the binding, basically. Okay, and otherwise we return a error. And in the next commit, I think I will rewrite that thing to a visit, but let's build, and I think code will fail now. Or I think it will fail in the C++ stage because it will just pass it will try to pass a range to save array access, which is obviously wrong. And I think we can implement the access for the slice, but like you give if you give a slice a range as the index, you will get slice in return, and we need to do this anyway. So let's copy. Let's copy this thing. Range. And also here we get range. So if range begin, oh, I need to add this. How could I name this like begin and values? Because these are added for C++ range for everything, but I would want to like begin and we can have start and or just first, last thing or low, mean. Let's name it mean and max. And also rename the variables or no. Maybe using other files, okay. Range. And then we, if range mean is greater than container size, something like that. I think that will be an obvious error, and then so what if we defined ranges backwards? I think there is no guard for that, so this will just fail some way. We can just add a check both value here, but no, what I'm doing here. This would be something like that, and then we need to return a span. So begin container plus range mean, begin container plus range max, and the same for immutable. So this will return, I think, this will return a const span, and this will return a non-const span, so immutable span. Yeah, and let's see. So now printing files, I think, is because this will fail to convert the span. Yeah, that's that mutability thing. We need to have a const span in the code gen. We even need to, so like if slice, if the qualified type is, so we need to know what's the type here, basically. And we can, I think we can even make this in the type checker. We need to do this anyway. So elements are mute. We add a variable. And this won't be reflected in the name, or we can even reflect it in the name. So it would be here. So elements are mute would return a mute, and otherwise we'll have a empty string. Yeah, so slice to mutable t, basically. And then when we construct the slice, we'll return a mutability based on the variable mutability, which is not ideal, but at least we have a proper framework for that. So, like on the type checker level, we distinguish these two, like mutability of elements and mutability of the slice itself, but you can't express this in the syntax just yet. And then when we code can, we do the same thing as with the name. So if slice elements are mute, we do empty string, and otherwise add a constant, then we'll need to have right formatted. Let's try to compile that and see. Okay, so it compiled, but let's see if it runs. So I think it's yeah, it worked. Yeah, because we don't include it as element, so so it's working, or no, because we have wrong conditions here. For max, we don't include the last element. So let's do this, and let's also add some more tests, I think. So out of range, this should panic. This should panic with array out of bounds, and slice partial, I think. We should just take a part of the array and see if that works. Yeah, that prints 1, 2. Yeah, so that's correct. And then this should be okay. This should no, this should be okay, and this should fail. This should panic. Let's add expectations, and also for the base test. Yep, and out of range. Slices out of range error. On this TDR, we have a panic. Nice. Let's run tests if Did we broke something? I think. Array index must be an unsigned integer, yeah. But well, I have changed the error message. That's true. So let's also update some more tests. Okay. Oh, that's here. Yeah. Let's see what fails. Invite member access. Nested postfix first. Not found operator, yeah. Okay, so let's also add this. And now test should run, I think. Yeah, 56 passes, nice. I think we can commit that thing. No. Yeah, so also this buffer thing I need to revert. And so that will be implement slices. Slices are a view into a contiguous memory that is owned by someone else. This is taken from languages like Rust, Zeek, etc. Note that we don't do any safety checks yet. Haven't I configured my username and user email? Oh no, okay. I will do that. Wait. Let's see. Yeah. And also, no. Let's don't push on the video. Okay, so that would be everything for today. Thanks for watching and bye.